Hello, everyone. It's Jamal Thompson. So, with me, another awesome guest for today. I have with me Guy Lane. He is environmental scientist and author, and I've just finished going through his book. Let me make sure. What Comes Next? Climate Change, the Future, and You. And that's going to be one of the books that we discuss for today. Guy, welcome to the show, and thank you very much for coming to the show.
Thank you, Jamal. It's a pleasure to be here.
So, like I said, I just read through your book. So let's set the basis for it. How do we get here? And what I mean by how do we get here, we're talking about a climate change catastrophe. You and I sat here and talked just before we came onto the show about pretty gloomy things that are taking place. And what I mean by this, the last show, I just had a gentleman from Extinction Rebellion on, and it kind of went through this thing of, you know, the carbon in the atmosphere is becoming so much where the nutrient density in the food has started to go down, like stuff that you don't necessarily predict off the top of your head. There's another thing about the extinction event that's taking place from the standpoint of the mammals that are on the planet. There's another thing about, you know, Exxon or the sixth extinction to some degree related to how we are going about our affairs on this planet. And a lot of that relates to, you know, how we go about our way. How did we get here? How did we get to this point where the United Nations is saying we have 12 years left on this planet? Not on this planet, I'm sorry, 12 years left to get our house in order. Let's say it that way.
Yeah, so a good frame of reference is the Permian extinction event that took place about 253 million years ago. This is one of 5 prior events in the geological history of Earth where there's been a massive extinction, which means generally 50 or more % of all the living things have gone. And what happened with the Permian was there was a series of volcanic eruptions that took place over around about 20,000 years. And a great deal of lava came out of these volcanoes and spread over what effectively were peat deposits or coal deposits. And as a result, basically burnt all this coal and released all of this CO2 gas into the atmosphere. The CO2 gas traps infrared radiation. A lot of that heat goes into the ocean gets hot, the ocean stratifies, which means it doesn't mix, which means that the oxygen doesn't get into the ocean. So the ocean basically died. Most of the things living in the ocean died. The ocean produced a type of bacteria which produces hydrogen sulfide gas, so that would have toxified the atmosphere. Most of the things on the planet died, 70 to 80%.
Oh wow.
We're doing exactly the same thing on planet Earth. We're just doing it 100 times faster. And what we're doing is we're burning fossil fuels, just like in the Permian extinction. Instead of it being a volcano, now we've got the global capitalist industrial system on this planet with 7,000 people using as their primary energy sources fossil fuels. And when you bring those from under the ground and burn them, you put the carbon into the atmosphere. That's really basically what we're doing. And so the solution to that, obviously, is to stop doing that and do something else. In order to do that, we need to move away from fossil fuels onto renewables and to disciplined use of energy. But also, because we put so much carbon in the atmosphere already, we've got to pull 1 trillion tons of CO2 out of the atmosphere just to get back to where we were, because the place where we were is sort of the safe zone, and we're in the danger zone right now.
What is the Anthropocene? Anthropocene.
So if geology, you know Jurassic Park, the movie? So the Jurassic is a geological era. It's a time. So the time that the humans have actually grown up with civilization, which is over the last 12,000 years, that time frame is called the Holocene epoch. And the geologists are now debating whether or not we're actually in a new geological time frame that they're calling the Anthropocene epoch. And the Anthropocene is the period in which the humans are the main drivers of change on the planet. And the argument at the moment is not so much whether we are, because it's clear that we are. We cycle more carbon into the atmosphere than nature does. We cycle more nitrogen. We move more soil than all the world's rivers and dust storms. So we are, without doubt, the biggest driver of change. So we are now in the Anthropocene. The argument is, when does it officially begin? Mm-hmm. And so one of the arguments is that because it's a geological frame, then they need a geological marker. And so one of the arguments is that the Anthropocene started around about the mid-50s, which could be seen in geological samples because of the radiation levels that were left down from the nuclear bomb tests.
Yeah. That's fast.
So the Anthropocene also becomes a term that just describes the modern age in which the humans are causing havoc on the planet.
And havoc we are indeed causing. I mean, after all, they gave us like a 12-year. And by the way, that number, it's not really 12 years, right? I mean, we don't know what that number is. I mean, that number, that's some estimate that these guys made, but it's no reason to believe that our natural processes is going to be in this kind of structured falling apart where they can completely predict how things get worse and how certain factors interact with one another in the collapse.
Yeah, and look, that 12 years, I mean, there's different numbers. I mean, I think part of it, it's a political term that sort of, on one hand, it's like, you know, and what is the 12? What needs to have happened by 12 years? That's sort of a little bit open. There's also another one saying that we've got to peak carbon emissions within the next, by 2020 or something, which is like 18 months or whatever it is. You know, so I think the 12 years is basically that we need to have started to decarbonize the global economy and be well underway for that. And this is coming out of that recent report from the UN 1.5C that came out in about December last year. And what was really interesting about the 1.5C report compared to all of the previous reports, because the Intergovernmental Panel on Climate Change reports every 5 years on the science of climate change. And this is the core documents that the world's governments base their climate policies on. But what's been made very clear is that that whole process of reporting climate change is deeply flawed, because climate is moving so fast. The climate is changing so fast that you don't really want to have a 5-yearly update. You really need to have, you need to have a monthly update, really, not 5-yearly. And secondly, because it's based on peer-reviewed science journals, it can take a couple of years from when a researcher comes out of the field with his data to actually getting the paper published in the journal. And then, because of the rules of the UN reporting, it's actually got to be in the journal for 2 years before they accept it into their report that comes out every 5 years. So what you're actually finding now is governments are basing their climate policies on data, some of which goes back 9 years old. And then they're not fulfilling their promises that they make on the basis of the 9-year-old information.
Well, that's so the Paris, and I'm being facetious when I say this, but I thought Obama and Macron fixed it with the Paris Accords. Like, the Paris Accords didn't just solve all of this where we can just go home and act, you know. Well,
no, what it did, though, is it reaffirmed the commitments of governments that there was a problem. But if you actually look at all of the pledges that the nations made under Paris and you tally it up, that's going to take us to 3.5 degrees Celsius. That's assuming that they actually do the thing that they've pledged to do. And look what's happened with America. They've actually just pulled out and gone in reverse.
So even under the best of conditions, it is inadequate. That's what you're saying.
It was wholly inadequate, yeah. But it was the best that was possible at the time. Because remember the governments the governments don't behave, don't do their jobs. Their job is to look after the interests of the public. I mean, but what they do is they look after the interests of the corporate interests. Yes. And so, you know, that's the best that they could get an agreement to.
Which is sad, right? I mean, like Donald Trump, in one of the documents, that was the thing I was trying to remember. In the document, it's saying in 2100 it's going to be 7 degrees Fahrenheit. Yeah. That number, that's insane. Like, that's a mind-blowing thing for a guy who.
Yeah, I think that was 7 degrees Fahrenheit, was it, or 7? So yeah, so it's about 3 something.
I mean, that's amazing.
Look, here's the other important thing about Paris, and I'm always trying to find analogies to make it easy to understand. Imagine if you're down the cliffs down by the seaside, and you've got your kids with you, and you say to your kid, whoa, don't go too near the cliff, and the kid says, what's the safe point? Okay. So the safe point, okay, is not when his toes are right on the very edge of the cliff, right? The safe point is actually in the baby seat in the car park, right? Okay, but you say, no, don't go more than, say, 50 meters close to the edge of the cliff. What the Paris Agreement did was it set this 2-degree target, okay? We can't go beyond 2 degrees. 2 degrees is falling off the cliff.
Yes.
So they actually set the target at the edge of the cliff. And if you read the documentation, that is a 66% chance of not falling off the cliff, not a 99% chance. And so here we've got this.
That's so sad.
It's madness. And that is the basis of which the world is moving towards fixing the climate change problem.
Now, go ahead, I'm sorry.
That's it, madness.
In your book, you make really good analogies in order to try to make this stuff relatable.
Yeah.
In ways that people can understand it. Because, climate change, it's not like, I often describe it as an asteroid that's about to hit the planet. And I describe it in that way because I try to create this visceral reaction of being able to walk outside your house and see a huge boulder, coming to Earth at some blistering speed. And you were like, oh my God, or, we're about to die. This type of, Bruce Willis getting on a spaceship in order to do some kind of heroic deed or something. Because people can, you can see that, as opposed to there's amorphous climate change that's happening. The blue ocean event. Now, you made notion of the blue ocean event, and you said that's going to take place, and people need to get prepared for that to take place. And there can be certain outcomes. So first, what is the blue ocean event? And then I kind of want to go to potential outcomes that you see after that event taking place.
Okay. So over the last millions of years, in the northern part of the planet, the Arctic, in the summer, in the winter time, which is like 6 months of dark and then 6 months of light in the summer. In the winter time, the whole place is just basically frozen over. And then when the sun comes up for 6 months, the ice retreats. It doesn't go all the way down to zero, but it comes back, and then the winter comes and it goes. So every year, over millions of years, there's cycles been going on. But since around about the 1990s, every year the summer sea ice has decreased less and less and less and less and less and less. And if you extrapolate the trend, then sometime in the next few years, which is 2 to 3, maybe 4 to 5 years, they're going to get down to zero ice in the Arctic, Ocean, probably in the height of summer. Now, that is really important because of a couple of things. Firstly, is what they call Arctic amplification, which is the reason why it is getting the temperature extremes are so high in the Arctic, which is to say that the global warming is showing up more in the Arctic than other places, is because of these positive feedback loops. And so, for example, when you've got a lot of ice on the sea, then when the sunlight comes down and strikes the ice, white reflects the sunlight back into space. It's called that albedo effect. If you've got less ice, then you've got less of that energy being reflected back into space, which means more of that energy is going into the water, which means the water's getting hotter, which means you're melting the ice faster. So that's called a positive feedback loop. The opposite happens in a refrigerator, where as the temperature increases, then the compressor comes on, and then the temperature goes down, the compressor goes off. That's a negative feedback loop, and that keeps the temperature of the refrigerator constant. If you've got a positive feedback loop, your temperatures are going to spike. The other aspect is, and this is the really scary one that most people don't understand, is to do with the latent heat of ice. So this is the ice cube in the glass analogy.
Yes.
So the amount of energy required to melt a gram of ice would raise a gram of water by 80 degrees Celsius. And so a lot of the energy that's in the ocean is currently being absorbed into making the ice melt. But as soon as the energy is no longer going into making the ice melt, it's going to make the temperature of the ocean go up. And then what happens, this is the blue ocean event, was when all of the ice goes. And then what's going to happen is you're going to lose the dipole. So the dipole is this idea that the temperature of the northern hemisphere is driven by the temperature difference between the Arctic, which is supposed to be really cold, and the equator area where it's nice and warm. So you've got cold at the top, warm at the bottom, and then you've got this circulation of air, and that's what drives the weather systems of the northern hemisphere. Well, as soon as the Arctic Ocean gets hot and the tropics remain hot, that whole system is going to collapse. And so this is a tipping point in the Earth's climate system, which we can see coming towards us, and it's 2 to 3, maybe 4 years out. And you can see that every day updated on the grass, because they've got these satellite data that go onto grass, and you can see every day what the total area extent of the ice is, and you can just see these trends. And if you extrapolate the trend 3 to 4 years from now, then basically you get more or less down to zero, and that's when it gets really, really, really spooky on this planet, climate-wise.
And this is, like you said, the ice cube effect. So this is the idea where if you have a cup, you have ice in that cup. As long as there's ice in the cup, the temperature, for the most part of the water, remains cold. But the moment that the ice evaporates from the cup, at that point, the surface temperature or the external temperature of the glass starts to impinge upon the water, which increases the temperature of the water. Like you're getting this kind of the thing that was keeping the earth cool to some degree evaporates. And not only does it heat up from the standpoint of the ice not being there, but it also heats up from the absorption of the energy of the sun itself. Like there's a lot of stuff that's taken place where it's like you've completely decapitated one of the key systems that maintain the balance of temperature on the planet itself.
That's right. It's like we've blown up the natural air conditioning system of the planet. And so this isn't discussed in the book, but here's another issue. I did an interview the other day with Jennifer Hines, who's a citizen journalist who did a lot of research on Arctic methane, right? So this isn't discussed in the What Comes Next book. It will be discussed in a future book. But there's a lot of methane in the Arctic, and methane is a greenhouse gas which is about 100 times more potent on a sort of mass by mass basis than CO2. There's a mountain of the stuff in the Arctic. It's tied up in the permafrost, which is the permanently frozen ground, but it's also tied up in this ice crystals on the seafloor, and particularly in the shallow East Siberian Sea. And as the temperatures of the ocean go up, then more of these ice crystals are basically melting and releasing this methane. And the methane is a powerful greenhouse gas, which is adding even more heat into the Arctic. So there's a whole sequence of things taking place in the Arctic, which are already destabilizing the climate. So when I was speaking with Jennifer the other day on this interview, she was in Colorado, which has been hit by this big cold snap. And the reason for that is because of the destabilization of the climate in the Arctic is leading to the jet stream to become extremely wavy. So normally the jet stream is this high altitude wind that whizzes around sort of pretty much like this, but now it's starting to get all loopy. And in those loops, you get the Arctic cold in the loop. And the thing's actually also parking. So what you're finding is that you're getting these intense cold weather systems that sit in place for like 1 week, 2 weeks at a time. So it's starting to appear all over the Northern Hemisphere. So you can expect to see more of this sort of climate chaos. And what this is leading to, apart from anything else, it's leading to natural ecosystems are becoming harmed by this. And so the whole fabric of life on this planet is really coming apart. And it's all underpinned by the fact that the humans continue to use fossil fuels as their primary energy source.
What happens if the jet stream shuts down? I remember, like, the argument that you're making here essentially is we're adversely affecting even the jet stream itself. Like things like wind currents are being, you can say, broken in the way that they typically go about their way. What happens if that's shut down? I've heard the argument that if we keep this up, that the jet stream itself may literally shut down.
I don't know if shut down is the word that they use, but it becomes extremely unstable. So rather than having a regular pattern, so in natural living systems, they have what's called a dynamic equilibrium, which is sort of where, you know, like if you look at rabbit populations and fox populations, they sort of go up and down, but within a narrow band. Yeah. And so the jet stream basically whizzes around the top part of the Earth. It's at high level. It's a stratospheric wind. And so what's happening now is just becoming extremely wavy, and you're starting to see these pockets and these loops come off. And so what has allowed human beings to go from basically a naked ape 200,000 years ago to the modern civilization has been a window of stability of the climate over the last 12,000 years. That's gone now. So the stable climate that we've had over 12,000 years, that is history. And so what we've now got is 7.7 billion human beings on this planet in this highly complicated global economy where, you know, food production systems alone are spread across the whole planet. That whole system is now going to fall to pieces. The whole system is coming down. And some people say that is going to lead to the extinction of the humans in the near term. And others say, well, there's lots of different opinions on this sort of what comes next, if you like, and that's what I try to cover in the book, is to actually look at some scenarios rather than hanging my hat on one particular outcome. So I sort of address three broad scenarios. But what is absolutely clear is that we are going into collapse. We're not going into collapse. We are collapsing. Okay, the climate system is collapsing. The global ecosystem is collapsing. Maybe I'm not going to be an economist here, but you could sort of, with all the debt that's been built up, the economic system is collapsing.
Yeah.
So today is better than tomorrow. Tomorrow is going to be worse. And what underpins this is we have yet to stop doing the thing that is causing the climate change problem, which is pumping 37 billion tons of CO2 gas into the atmosphere, not to mention all of the other greenhouse gases, of which there are a dozen or so.
For those people who say that this is not real, that the temperature of the planet Venus, warmed up, and this odd argument that sometimes is made that something, that this is based on issues of the sun. This is nonsense, right? This is something that these guys are.
This is some of the best studied science on the planet. They've been doing climate science. The first climate paper came out in 1720, written by a French mathematician called Jean-Baptiste Fourier. He wrote a paper on the temperature of planetary spaces. I can't remember it. Fourier, interestingly enough, and he described the greenhouse effect. He described how it was that the gases in the atmosphere trapped the heat and held it overnight, explaining why it didn't get freezing cold overnight. Fourier is known today. Electrical engineers use Fourier transforms all the time. So the mathematics of Jean-Baptiste Fourier, nobody questions that. But that greenhouse effect, it's a little bit nonsense. The first climate paper where an assessment was made of how hot does the planet get if we double the CO2. This is called climate sensitivity. That paper came out in 1896, and that was written by hand because there was no computers to do the work, by a guy called Svante Arrhenius. And his numbers says that if we double the CO2 from its existing quantity, which was around about 290 parts per million, if we double the CO2, that is going to lead to 4 degrees average temperature rise. That's consistent with what the supermodels come out with today. This is basic science.
Yeah.
Climate science is basic science. The way that CO2 molecules absorb infrared photons is basic chemistry and quantum mechanics. This stuff has been known. So people that deny climate science, they're not doing it on the basis of a rational argument. They're doing it on the basis of some spiritual belief, religious belief, economic belief, vested interest, or whatever. And I because I write and I go in and I talk about this stuff in public, I have these people hounding me periodically, and I just try and shrug them off. It's just an annoyance. It's like a mosquito out on a.
It's weird to me because it's like you trust these guys for everything else. They build your planes, they build your computers, they build your laptops. They explain the universe, but on this very particular issue, it becomes political, and it's like, I believe that guy for 99% of that stuff, but not on this. It's like, why this issue?
Yeah, it's like you trust your doctor, but your dentist, no. Whatever a dentist says is just absolute nonsense. But the doctor, the oncologist, he's spot on.
Right. So what comes next? Like, I guess that's the pertinent question, right? Like, we were talking about McPherson, and you mentioned McPherson in the book, and McPherson kind of makes this point that we're screwed, might as well kiss it goodbye. But not everybody necessarily take that point of view, even though for the most part, all scientists take the point of view of this is problematic and this is extraordinarily troubling. Something needs to take place, dramatic something needs to take place, not, around the edges, this kind of soothing incrementalism. Oh, I recycled, and so I feel great about myself that I recycled. Not that. My wife hates it when I say recycling is not going to save, that and a dollar will buy you pretty much nothing. Like, I try to make the point to her that it needs to be significant change at a global level to have any kind of real significant effect on climate. Oftentimes, recycling just makes you feel better. It's like, oh, I threw this soda can away. Oh, I'm a great person. And it's like, yeah, you might be a great person, but that's not going to solve the issue, So what comes next? What's the...
Well, so what I do in the book, like I say, I don't try and make a prognosis about what comes next, but I look at three scenarios.
Yes.
And I just step back a little bit. Part of what allowed me to write this book, so I've been planning on writing a non-fiction book about climate change and sustainability for a long time, but there's so much in the subject matter that I really needed to sort of narrow it down. I needed to have a clear frame. And I found a book a few months ago. Well, I wrote this book in around September last year. And around about that time, I came across an interview with an astrophysicist called Adam Frank. And what he did was he looked at this question of, is there life on other planets? Is there civilization on other planets?
Yes.
And because in the last few years, we've developed these techniques of seeing exoplanets, which is identifying, we've got these mathematical and statistical ways of identifying that other stars have got planets around them, because previously nobody knew.
Right. It's like they find a small permutation in the wobble of the planet, or the permutation of the orbit of the planet, and it gives them this kind of
it's like there's a small perturbation in the intensity of the light, which is caused by the shadow of the planet passing into some of it, right? So once they actually found these techniques, they realized that most stars have probably got planets. And so if you go back to this thing called the Drake equation, which allows you to say, well, what proportion of stars have got planets, what proportion of planets are in the habitable zone, which is they're not so far from the sun that they are cold and not so close that they're too hot. And so you put and then what proportion have got life, what proportion have got intelligent life, what proportion have got civilizations, and then how long do civilizations last? So when you put this new data into that equation, what Adam Frank says is there are probably hundreds of trillions of civilizations in the universe that probably are all going through, because they've all got the same physics, right? The physics is the same everywhere. They've probably all got fossil fuels. And civilizations, in order to grow, need an energy source. And what is the easiest energy source to exploit is to dig up the burnable stuff under the ground. Out of all of the hundreds of trillions of civilizations in the universe, they're probably all going through their own Anthropocene crisis, just like we are. And what he does is he sets up a big computer model and he models it. And what he finds is out of those, there are probably three broad outcomes. And these are the three scenarios that I paint in the book. They probably either go extinct. This is the civilization taking down the ecosystem with them. They probably collapse but survive. So this is the collapse, but there are still humans left model, or they figure it out. And so the way I refer to this in the book, I said it's either drowning, near drowning, or learning to swim. And so that's my three frames. This is the three, what comes next. I don't know which one it is. If I had to make a guess right now, it would probably be near drowning or maybe drowning altogether.
Yeah.
I don't see evidence yet of us learning to swim. I haven't seen, there's stuff going on. We've developed some excellent technology, solar power technology, for example. But if you look at the growth of the global economy, the growth of energy demand in total, then the growth of the renewable energy industry just isn't keeping up. So we actually still got, the largest carbon footprint ever last year. So those are the three scenarios. The Guy McPherson near-term extinction model, or maybe not near-term, but the inevitability of human extinction and most of the creatures on the planet going extinct, or what I refer to as a rerun of the Permian extinction. That's one scenario. The other scenario is a collapse, so all of that stuff, but it doesn't wipe everything else, that we still manage to maintain some semblance of civilization, or somehow some amazing enlightened period in human evolution comes along and we figure out how to do what we need to do. We know what it is we need to do. We just don't know how to do it.
Ooh.
We don't know how to turn off the power of the fossil fuel elite, basically. That's at the heart of the problem. The industrial, the human beings who are in command of the biggest corporations on the planet are the problem.
I agree with you. I agree with you. I think it goes, there are plenty of people who shop at Walmart. And those people shop at Walmart, even though the communities that have Walmart, I think they lose like hundreds of thousands of dollars just by Walmart being in the area, because people have to pay services because Walmart doesn't pay their workers and stuff. Even despite stories showing that people who work at Walmart, some of those people during Thanksgiving needed to get like canned goods because they couldn't afford, but people still do these things. Now, they do these things because they get a benefit from buying products that are dirt cheap from Walmart, despite the environmental costs of shipping those things across the world, despite the human costs of them not paying them people a decent wage. while simultaneously the Walton's getting billions of dollars. Like it's, I would argue that it's the system itself. Like it's not, it is a super elite. Don't misunderstand me. They have every incentive in the world to maintain, you know, like ExxonMobil. We were talking about ExxonMobil knowing back in the 80s that that climate change was an issue. Like you said, their own scientists knew these things and some of the best science, and they attacked the issue. But even from an individual standpoint, the incentives themselves tend to go towards maintaining the system the way it is. I would argue that it's somewhat of a systemic issue. Right? Yeah. I mean, am I insane on that? Like, for example, if you were part of the super elite, would you behave in the way that they behave? Probably.
Well, this is a really good question because it's abundantly clear that unless there is systemic change in the way that the planet is governed, and that we're heading into this collapse. Now, you know, in those three scenarios, right? If we don't do anything different, then we're going to foreclose on two of those scenarios.
Yeah, right.
So those three scenarios exist in my mind today, right? But 5 years more business as usual, we're not going to have any chance, right? This is the part of this time frame we're in. We're in the last throes of this game. The change, if any systemic change happens, it needs to happen now. Otherwise, we are going down the Guy McPherson path. And so this is the bit that I still haven't quite got my head around, and I continue to do my research to understand power and where power lies on the planet, is that these people must know what's coming. And there's no bunker big enough to hide from a rerun of the Permian extinction. So it may well be that these multi-billionaires are building these big bunker complexes, but wouldn't they rather actually live on the surface with sunshine and rain?
I agree with you, but it seems like that under normal circumstances, the life of a person who has $1 billion is dramatically different than the life of 99% of the people on the planet. They are so far removed from that stuff. You know, they still get colds and everything else. They still people, but it's very possible that they think they're immune or they're distinct, because in many of the things that take place within the society, they are distinct. Like it's you know, if you get a very tiny percentage of the population that is controlling the rest of the population, you're going to get skewed outcomes. Those percentage is going to skew how the society runs in the direction that is in their best interest, which is essentially what we have. I think your thing is, but don't they know they're running it into the ground?
Well, and I think, and as I try to get my head around this craziness of this situation, I'm thinking now back to a writer called Susan George, who writes about like power. Mm-hmm. And she said, she refers to them as the Davos class. And these are the people that go in the private jets to the Davos World Economic Forum. And she says that they lack ideas. Now, I've just come through a Master of Business at a prestigious university in Queensland. I've got a couple more units due to complete it. But in 3 years of full-time study as a Master of Business, not once did any one of those tutors tell me that we live in a carbon-constrained environment.
Oh, it doesn't apply.
Apart from anything else,
it doesn't apply.
Apart from anything else, the university system is punching out thousands and thousands of graduates who don't know the first thing about climate change or sustainability, and they're engaging in this global economy and to maximize shareholder value through growth. Yeah. It's suicidal. And so you can start to see how the people who are at the top, they have not been informed, and clearly they're not looking out for this information on their own. There is probably not a lot of billionaires listening to you and I talking about how the billionaires run the world so badly. And so that starts to make sense. They just don't get it. And if you hang around business elites, and I don't hang around a lot of business elites, but the higher it seems you go around business people, they're really busy. And they haven't been trained in ecology. They haven't been trained in science quite often. I was at this is not a business elite, but I was at this event at the university a while ago. It was this lawyers event. It was the room full of lawyers. And I was talking to this guy, and I said, look, you know, species extinction. And he looked at me, and this guy's like got a top law degree in an Australian university. He said, what's a species? And I'm like,
way.
I mean, how can we have a conversation about sustainability when people are coming out of universities with no grounding whatsoever in the basic ecosystems of how the planet works? And so then it all starts to make sense. They don't get it. And they listen to people like you and me, or they listen to people talking about climate change, and they're going, what the hell are these guys even talking about? You know,
the goal is to maximize profit.
What the hell are they even talking about?
I mean, it seems like it's maximize profits at the expense of everything else. Because keep in mind, carbon, like you say, it's a waste material. I mean, they've dumped trillions of that stuff into the atmosphere. They're not paying for that. We are. Like, even if we're talking about carbon capture technology, it's more likely than not we, the taxpayer, are going to have to pay for the fact that, you know, they're pulling that stuff. Whatever that solution is, we're going to take the hit for something.
Yeah.
Thing was created, like 70% of the companies created the majority of the, or like a small percentage, I'm saying it backwards, but like a very small percentage of the companies created the majority of the crisis.
Yeah. 70 companies produce 80% of the CO2 or something. And look, it's a classic case of privatize the profits and socialize the pollution and the costs.
Yeah.
And this comes back to this idea of this structural issue. The reason why you've got Walmarts and like those super wealthy families is because of the laws of the land, right? So so it's what I call legal theft. You know, they're stealing all of this money for their families from the masses, but it's legal. And it's legal because the government system acts on behalf of the corporates, not on behalf of the public. And this is where, when we come down to trying to figure out what happens, you mentioned Extinction Rebellion, which I think is one of the most brilliant innovations in this space that I've seen. I mean, I've been doing this stuff for 16 years, and I've never seen anything as clever and potentially as successful as Extinction Rebellion. When that starts happening, when that starts going properly, that is going to turn governments upside down. And that's when you're going to start to see guillotines and pitchforks coming out. And that's when you're going to start to see potentially the change in the system, because until that system changes, we're basically heading to hell in a handbasket.
I hope so. I told the guy that he was doing God's work, and I believe it. I mean, you know, the world is at stake, and you look at this and you think to yourself, well, if the world is at stake, certainly we have to do something better than what we're doing, and not so much. I mean, it's like this boat keeps on rocking. Any innovative ideas? So, you know, one idea is not to put the carbon in the atmosphere in the first place. There's that. Like you said, 10 years after we stop putting carbon into the atmosphere, there's still this heating effect where the world continues to heat up. So, you know,
it's the lag.
Right. Yeah. Lag. Yeah. Even if we stop right now at this very moment, there's still 10 years of heat built into the process.
Well, it's even actually a little bit more dramatic than that, because this is part of what I find so fascinating about climate change, is just trying to get your head around all of the jigsaw pieces.
Yeah,
it's like a complicated machine with lots of cogs, and then you go, oh, hang on, there's another cog over there. Where does that one fit in? So if we were to stop burning fossil fuels overnight, which of course we can't do, it's going to take decades for us to transition away from fossil fuels. So hypothetically, if we could turn off all the fossil fuels overnight, we would have an immediate increase in global temperatures, because apart from the CO2 emissions contributing to the temperatures going up, what comes out of the smokestack of particularly coal-fired power stations is also sulfur particles. So if you get sulfurous, like dirty coal, they call it dirty coal. You hear clean coal, that's coal that doesn't have a lot of sulfur in it. When you put the smoke, if you see those photographs, particularly in China, where the huge areas all covered with all of that smog, well, what that smog is doing is actually reflecting some sunlight. And so if you turn off the coal generators, then all of a sudden all that smog goes away, you get more sunlight comes in, and you get a heating effect. So that's called the aerosol masking effect, or global dimming. So the first thing that happens if we turned off the generators overnight is the planet actually gets hotter. And the numbers suggest that somewhere between about 0.5 degrees Celsius and 1.5 degrees Celsius, I think maybe a bit higher, is the sort of average global temperature increase that we're going to get if we turn the generators off. So if you think that 2 degrees is the edge of the cliff, right, and 2 degrees is above what the temperature was, global average temperature in the beginning of the Industrial Revolution, we're already about 1.2 degrees above that temperature. If we turned off all the generators overnight, we'd go beyond the 2 degrees.
That's amazing. That's
so
that's so disturbing.
We need to turn off the global fossil fuel industry in a very, very orderly manner over the next 2 to 3 decades, whilst we're ramping up the renewable energy industry. And remember, in order to make all of this renewable energy, we need to use fossil fuels to get the power to do it.
That's the other part. So how does that work? So in order to make solar power, let's say solar panels, you need fossil fuels in order to make the solar panels?
Well, solar panels are made of aluminium for the frame, glass, silicon. All of that stuff is going to be extracted from the ground. So if you want to get bauxite, you use diesel fuel, okay, to drive a bulldozer, and then you use coal to run the electrolysis devices, and then you got to use diesel fuel to transport it, and then you got to run your factory. Now, eventually, you'll have renewable energy to use to build the renewable energy, but we haven't got enough renewable energy to go around at the moment.
So in the ramp up in order to even get to the point where you
so you can see, if we're actually going to fix this thing, we need to have not only global cooperation, but we got to have some way of having capitalism actually work on behalf of the planet rather than work on behalf of the existing shareholders and corporate executives. And so that's the question. How do we get that? Now, the only analogy that I've got of that is basically what happened in the Bretton Woods institution at the end of the Second World War. So it took a global war for the leaders of the countries that looked like they were about to win, because that's happened before the end of the war, for them to get together to reinvent the system, which then became the dominant economic and financial system on the planet. We need to have another one of those. But how are you going to get that without having a third world war? That's the question. Because apart from anything else,
get people's mind focused in a way where they're attenuated to it. You know, like, because it's one thing to say, hey, we need to do something about climate change. And people may agree saying, yeah, that's important. But how important things in their life is always going to take prominence unless something takes place where it puts that in their mindset. So do you see a pathway out? Like, do you see a path, dancing between the raindrops in order to try to make this work? I got to be honest, I am somewhat down on this idea of, I don't see the change. Like, I don't see this thing of, we have a president who says it doesn't exist. And then in his own scientist saying, okay, well, it exists, but we can't do anything about it. Like that stuff, like where it's not even a real honest attempt of saying an attempt based on the scale of the problem. The world is at stake. And instead of people, instead of what's his name, getting in a spaceship, he's sitting on his hands. Like it doesn't give me hope. Give us hope. That's what I guess I'm asking. Where's hope?
Hope based on nothing is not helpful, but hope based on evidence and sensible ideas is very valuable. So I'll try and do that. What Adam Frank says in his book, Light of the Stars, where he talks about the hundreds of trillions of other civilizations all going through the same crisis that we're going through, he comes out of that and says that he believes that a quarter of them survive. Okay, which means that 3/4 perish, right? So the odds aren't in our favor overall if we're using. And so what I really like about that frame, it's the first time that I've actually been able to think about sustainability and collapse outside of being on the planet. So here's a guy that's canvassing the entire universe and saying that we're going through what everyone goes through, and that most of them fail, but some of them survive. That gives me some reason to go, okay, so here is a frame that says we can get out of this. Now we just got to figure out what to do. And in having this conversation and outlining the idea of like the Bretton Woods meetings and creating this grand, we got a clearer picture of what we need to do. The question is, how do we do it? How do we get past the roadblocks? And so what we're doing in this conversation is we're actually starting to map out some of those stepping stones and identifying the bits that we don't know. And so there's a lot of people working on this, and I'm of the opinion that we have yet to see anything that approximates, like the Extinction Rebellion is very brilliant, and it's only started recently and it's quite small at the moment, but there's going to be lots and lots of these other things pop up, and that creates a new focus of attention. Also remember that the fossil fuel industry is very vulnerable. Apart from anything else, there's a phenomenon called the carbon bubble, which basically says if you look at all of the, if you look at how much carbon we can burn still burn and not go past the 2 degrees targets. And then you look at all of the fossil fuels that are listed as assets on the books of the fossil fuel companies, you know, the reserves. Yeah. So BP, for example, owns this patch of the ocean, which has got all that oil in it. Well, there's 5 times as much fossil fuels listed as assets in the books of the fossil fuel industries as there is capacity for us to burn it. One day, when the market wakes up to, it's like having a warehouse full of suits. Okay, and that's you're a wealthy company because you sell suits and you've got this huge stock of suits in reserve. And then the government bans selling suits. Your company value goes down. So when the market wakes up to the fact that most of the value of the stock price of the fossil fuel companies is basically worthless because you can't burn all of that fossil fuel, otherwise we're going to trigger the extinction of the human race, the fossil fuel industry is going to collapse.
Oh, see, I am far more cynical than you are on this. Like my cynicism, like, and I say that to say, like, so 2 things. The guy who's making the predictions about the Drake, using the Drake equations, I agree with the Drake equation thing. I think, you know, there are more stars than grains of sand on the beach. I mean, come on, there has to be something else out there. I always thought it was weird that those questions weren't asked, or that people engage it with a giggle factor. It's like, why is that a giggle factor? We're ball hurling through space. I mean, that's literally what we are. We're not any different than any other planet. You know, you have life that grows on volcanic pits. You know, I mean, it was like, so this idea, like, you know, life is most likely ubiquitous. It probably grows everywhere where it gets opportunity to grow. Yeah. Now, the secondary question though is, are they like us? Meaning, did they develop a system of economics that propagated a certain behavior that destroyed the planet? Because we don't know that. Like, it's very possible that the system that we've developed on this planet, in an odd way, may be unique, maybe not. It's hard to know how that stuff breaks down. And then let's be honest, our issue with the standpoint of us is the system itself. Like, we've organized ourselves in a system where maximizing profit and deifying this thing of the individual and profit and all this other stuff, even at the expense of it. The capitalistic system is not real. This is like, it's almost like a religious belief. Yeah. It's almost like a bubble around reality, per se, you know, where reality is impinging upon the bubble, and they're just kind of ignoring the fact that reality is impinging upon the bubble. Yeah. But do they get to a point where they say, okay, enough? And that's the question for me that I don't have an answer to. Do they, like, is it, all right, these assets are going down and people are going to stop it? Or do they keep this boat rocking until the end, thinking, hey, when all the ice goes out the Arctic, we'll be able to get to the oil underneath the ice? That type of
I think that the crazy psychopaths who run the world are not going to stop. Okay, so what needs to stop is the public needs to stop being so apathetic. Yes. Okay, because every time, this is where Extinction Rebellion comes in, is basically the crazy people. The crazy people are few in number. There's not many of them. Okay, and the common people are large in number. And as soon as the common people can become organized and have effective leadership, then the system flips over really quickly. I mean, look what's happening in France with the yellow vests. You know, and they you know, they cut the head off the king when that. And so this idea that the elite basically becomes drunk on power and makes consistently bad decisions just plays out throughout human history, and that's really exactly what's going on now. But the difference now is that they've got G4 jets and they can fly around the place. It's a globalized system. There's vast amounts of wealth and power. And so it's a much more difficult, because it's not going to happen one country at a time. Because if you have let's say, for example, Australia had a socialist revolution, well, you can see the pressure of the Americans, who are military allies, because we've got Indonesia to the north and China to the north. The global system will make sure that nobody steps out of line, which is why there's got to be this sort of global revolution. Now, how do you actually put that in place? I don't know how you put that in place. But again, these are parts of the questions that need to be answered, and there are smart people thinking about this stuff.
Now, when Bernie Guillotine, he says, all of this talk about fossil fuels, how do you address the carbon footprint of 1 billion to 7 billion humans in 2 generations? Nobody wants to, because solutions are grim. I think you mentioned that in your book, saying like the amount of topsoil that human beings put over, the amount of action that human beings take across the planet, for the most part, you know, is overwhelming anything else on the planet. You even went into the weight of human beings in livestock in comparison to everything else. Yes, I did read the book.
Yeah. So this was a study came out last year, and they looked at. It's an excellent way of help get your head around the scale of the problem. The term is biomass, and so biomass basically relates to the weight of a living organism. So if you collected if you looked at all the biomass of all of the mammals on the planet, all of the mammals. So mammals are humans, dogs, elephants, whales, bats, mice, rats. You know, mammals, kangaroos, antelope. These are all mammals. If you measured the mass of all of the mammals on the planet, 4% of those are wildlife, and 96% is humans and our livestock.
That's amazing.
I mean, it's like, this is part of, it's like this thing is, I've been doing this for 16 years, and something like that, I'm just like, you are shitting me.
That's
it's just absolutely stunning. To give a clear sense of what we have done on this planet, where we have got to. And we can't continue to do that, because it's not just climate change. Climate change is one of 9 planetary boundaries. Okay, so the planetary boundaries is, if you like, the fault lines in the global system, and this is about the global system, the living system on the planet. Imagine there was no humans on the planet. This thing's been going on for 3.8 billion years. That living system, that integrity of that living system, has got these fault lines in it, and they're called the planetary boundaries, and climate change is one of them. And we have stressed all of them. And so, I talk a lot about climate change, but what I don't talk about is ocean acidification, or what I don't talk about is ozone depletion, or what I don't talk about is the nutrient pollution in the ocean, the eutrophication of the ocean. There's all of these other fault lines, and they're all happening at the same time. And they've all gone up on this exponential curve since around about the 1950s. And so there's so much going on. And so trying to figure out, it's not just if we've got enough brains and science on this planet, and we've got enough money and technology to do what we need to do, we just haven't yet figured out how to have the right people making the decisions.
It's like, it's the human element. I often say, there's nothing, if there's a robot that can do a job better than a human being, I want that robot to do that job. Like, I don't want a human being walking upstairs if there's an elevator that can take us upstairs. I don't want a person dropping French fries if there's a machine that can do it. Human beings are imaginative and everything else. I don't want them doing it. Now, the catch to this is the system itself. Because if you have Uber, if you could put a solar panel on an Uber car, and a person can just call their app, it goes from point A to point B. It never needs to stop for gas or any of that other stuff. That's great, except that like 100 to 200,000 people in the United States just lose their jobs overnight.
Yeah.
And that's essentially what Uber wants to do. They have the automated cars, and I don't blame them. Why wouldn't they? I mean, from a capitalist standpoint, they maximize their profit. They can the problem here is the way we use technology. Like, that would be an awesome thing if you didn't need to have a car. You can just dial it and the car comes to pick you up. Or better yet, public infrastructure where you can, go from point A to point B without having to use a car at all. Like, God, man, I agree with you that there's enough brain power to come up with solutions to this particular problem. How we get to configuring that brain power into a way that's actually trying to look at real solutions that aren't necessarily held within the bounds of the system itself. Meaning, even if that solution meant that the system itself needed to fundamentally change, that's the hard part. That's like the hard question. How do you get people to realize that, hey, nothing in nature grows forever? Sustainability makes more sense as opposed to infinite growth. It's like, how do you?
Well, look, it's already there. There's already people. There's already lots of people working on this stuff. There's already people who have got their head around this big problem and are putting in place little pieces of the solution. The question is, how do we get that groundswell of all of those good things to rise up so that they become bigger than the bad thing? It's like a sort of a balance. Look, I don't know, but all we can really do is continue to try and understand the problem, look for the solutions, and implement them as best we can. We're in a really interesting time right now because we just don't know there's so much we don't know. It's sort of like what we don't know, we don't know. It's sort of just been exposed to us. We just had an insight as to how little we actually know. And it's fascinating sometimes when I read these various science papers to realize that with all of these advancements that we've got in our technology and everything, that we still know so little about nature.
Yeah.
You know, there's so many things that we simply, it's like, haven't figured out yet. So this is it's an exciting time to be alive, assuming that you're awake to this. This is not a good time to be a climate denier, right?
I love it. It's an exciting time to be alive. And it is, by the way. I mean, chaos can breed interesting outcomes. Like sometimes, being posed a question can give you to these kind of evolutionary jump points. I mean, like you said, that's the question. Does humanity get to the point of exceeding the difficulties that it's facing, or does it, in Star Trek, and I'll end it on this one. I'll let you give the last word. But on Star Trek, humanity had to make this jump, but humanity didn't get its stuff together until everything fell apart, like the environment and everything fell apart. And at that point, people got tired of wars. They got tired of poverty and all this other stuff. And they grew up. But they grew up only when the environment and the system itself, like the habitable space, meaning the environmental system, collapsed.
Yeah.
I have this thing in me, this little childlike hope that humanity does something similar. That when presented with this kind of problem of existence itself, this existential threat to our living situation, that humanity exceeds it, that we grow up, just become rational human beings. And I don't mean rational human beings in the immediate sense of, oh, I can get a buck if I do this. I'm talking about rational human beings from the standpoint of a cosmic, perspective. This thing of we're living in a habitable space. The behaviors that we take on have to be within the habitable space. Otherwise, we're going to essentially kill ourselves. I would love for that to take place.
I really like your expression, grow up. And that's a term that I use in sort of looking at human civilization. So let me just go off on a little tangent here and again come back.
Go for it.
So one of this interesting science papers, so I read a lot on Gaia theory. Okay, so Gaia theory is the idea that all the living things on the planet behave in the manner of a single living organism. Well, one of the ideas in Gaia theory that's come out recently is that if humans were to go to another planet with some Earth species, to a planet that was in a habitable zone but didn't have life on it, we could actually go and reproduce Gaia on another planet. And so you've got this idea. And so what I and so the other thing is that we'll be in the habitable zone around our sun for around 2 billion years. But beyond that time, the sun is going to expand and basically burn up everything on the planet. So if you think about this, what is, this big existential question about why are we here? Well, see, for me, that is very simple. We are here because we were grown through this natural living system. And our role is to assist Gaia to exist on another planet sometime millions of years into the future. Okay. And so in order to do that, we've got to grow up and stop destroying the planet, because we've got to develop the technologies to take some of the living things from this planet to another planet in order that the living thing on this planet can exist beyond its natural birthright, because it's only got 2 billion years left.
Yeah.
That requires an emotional maturity of the human beings. And we don't have that at the moment. We've got people having their heads cut off because they've got a different religion. We've got the entire ecosystem has been pulled apart. We are an immature species. And it might be that unless we can grow up really quickly, we're just going to perish and then take out 90% of all the living things on the planet. But you know what? 20, 30, 40 million years later, the climate will have stabilized. All of the radioactivity material would have basically disappeared. And then evolutionary process will start off again. And maybe 250 million years from now, there'll be another intelligent species that can have the same question. And maybe they'll grow up faster than we did.
Hey, on the positive side, it may be a situation where it collapses. But like you said, this is the half-drowned outcome, where there's enough technology and everything else, and the remains of the civilization cobble themselves together and use prehistory as a lesson of how not to behave. Like, let's not repeat that. Kind of like the Romans. It's like there are elements of this that we take on, there are elements where we say are a bad idea, and we try to, it's like our failure is the success of somebody else. I'm trying to look at this on a positive side.
Well, yeah, you gotta have a smart. There's an analogy of a guy who was in a firing squad. You know, all the guys are there with the guns. Right. He's dancing like this, and the guy, you know, the guy who's leading the firing squad, he said, "What are you doing?" He said, "Well, this is the only thing I know to do. You know, I'm going to do this." Stop dancing. What? Are you going to shoot me? So what else do we do? We got to dance.
All I know. All I know. Oh, that's hilarious. Guy, I really appreciate you coming on and talking to me about this. I have, you know, like I said, Extinction Rebellion came on earlier today, and you coming on today, and in some cases, you're a follow-up to some of the stuff that came up in that interview, where it's like, you know, what comes next? How do you see the world after this, and that type of things. And in many cases, you're answering questions that Extinction Rebellion had a hard time answering. But to be fair to Extinction Rebellion, there's something to be said about being uncompromising with position. You know, in civil rights, they were uncompromising. Martin Luther King, X, all these guys were uncompromising in what they wanted to accomplish. I mean, even taking a peaceful route, that's not necessarily being compromising to what you're trying to accomplish. That's just taking a peaceful route and doing so. And Extinction Rebellion seems to be taking a cue from some of the civil rights groups and the way they're doing their protests and putting their bodies on the line and this type of stuff. And, you know, the world is at stake. So, you know, you can justify also, you know, yes, I'm going to jail, but the world is at stake. You know, there's these massive consequences. In many cases, I think you're answering that secondary question of what's next. What is the likely outcome if based on the scenarios that are most likely to take place? And I find that to be a fascinating question, a little depressing, but by the same token, the potential for something amazing if humanity can exceed its limitations and, like you said, grow up. So is there anything else that you want to add to this that we didn't necessarily talk about? I think we crossed a lot of ground on this, and I absolutely welcome you back to the show to continue this conversation. But
I'd be delighted to come back, and I think we've covered off a lot of ground. So I think we've done justice to what comes next: climate change, the future, and you.
Very cool. Well, you just named the book, Climate. What comes next? Climate Change, the Future, and You. I'm also going to put down the other book, Time to Wake Up. Climate Change is Now. I think.
Yeah. So the idea is, rather than writing one big book that takes all year, what I've been trying to do is to basically. There's so much in this, and there's so much to talk about in climate change space. So basically, to put out short books that can be read in 2 hours. That's basically the short 2-hour reads. Mm-hmm. And to put these things out every sort of 6 weeks or so. That's the idea. So I'm on track. I've got time to what comes next is the first, and then the others come in under the Time to Wait series. So Time to Wait, Climate Change is Here is the second book that I've put out just recently. So maybe I can come and chat about that next time I talk to you.
Absolutely, you're more than welcome to. Very cool. Guy Lane, environmental scientist, author, and awesome person to talk to on these matters. Thank you, Guy. I appreciate you coming onto the show.
Thank you, Juan. Bye-bye.
All right, guys, I'm going to end this here. I've done a ridiculous number of shows today and several interviews. So I'm going to thank everybody, and you all have a good night, and I'll see you guys probably tomorrow. Thanks all.